Ionic nomenclature is probably one of the most difficult topics that you're going to do all year. And what you need to do to start is memorize all the ions that we've given you. You really cannot master this topic unless you've done that. So that would be the first thing I do. The second thing is to recall that we need to produce an electrically neutral compound. So the overall formula unit for the ionic species must be neutral. So that's sort of the guiding principle that we're going to follow for ionic nomenclature, writing the formula and writing out the name of a formula, sort of going back and forth. So let's take a look at the first ionic nomenclature problem in this homework problem, and then I'll give you the answers and talk about the rest of the problems globally. So for A, we're asked to look at lithium phosphide. So the first step is to figure out what actually lithium and phosphide are. We know that lithium is in group 1. It is the metal it's written first, so it has to form a cationic charge, and the charge is going to be +1. Phosphide is the anion. It's a nonmetal, and it ends in "ide," indicating that it's monatomic. And since it's in group 15, we know that it forms a P3 minus charge. Now, it's not hard to see that we need 3 lithiums to balance out the charge for the phosphorus. But another way, a quick way to do it, is to drag the charges into the opposite species. So what I mean by that is, and you just saw the arrow, is that since lithium had a +1 charge, the number of phosphorus atoms we have to have is 1. Same thing for the phosphide anion. Since it's a 3 minus charge, that means that we need 3 lithiums. Now, I don't necessarily teach this approach, however some teachers might. It's not my favorite way of doing things, but it is a useful tool if you find it helpful for you. Keep in mind that the ratio has to be in the smallest ratio possible. So if you get something like lithium 6 P2, that would have to be lithium 3 P1. Finally, we acknowledge that we don't need the 1 subscript, so the answer should be Li3P. Now, we can also begin to think about drawing out a formula unit for this, and this really helps to think about the charges. So let's take a look at the next slide at our formula unit. We know we have a P3 minus anion, and there has to be 3 lithium cations surrounding it to give us an overall charge of 0. So that would be an appropriate formula unit for lithium phosphide. Keep in mind that it doesn't matter where you draw the cations or anions. We're just looking for the ratio of charges here. And that's how we get Li3P. Now let's think about the rest of the answers in a global sense. For ammonium sulfide, notice that ends in "ide," so it's S2 minus, and we need 2 ammonium cations to balance out the 2 minus charge on the sulfide. Note the parentheses, and the parentheses are important because we need 2 ammonium units, and you need to indicate that with the parentheses. If you omit them, it would be NH42 or H42, which obviously is incorrect. Silver always forms a +1 charge. Carbonate has a 2 minus charge, so it should be Ag2CO3. One other one that I'm going to highlight here is aluminum nitrate. That's Al3+. It always has a 3+ charge, so we should have 3 nitrate anions. Copper 2 hydroxide. Normally, you would think hydroxide would be monatomic because it ends in "ide." However, it's one that you had to memorize, so that's how we get CuOH2. Phosphate indicates in letter H that it's one that you had to memorize, PO43 minus, and that's a tricky one. We need 3 calciums, 3 2+ charges to balance out the 6 minus charge from 2 phosphates. So hopefully the rest of those are rather straightforward. Good luck with ionic nomenclature.